Hi guys, my name is Kevin and I am the SI for Biochem 110B Dr. Dingwall section. Today we're going to be going over briefly the ETC and OxPhos. You guys should know what these terms mean. Remember that you guys have a midterm coming up this coming Friday, May 1st. All right, so we'll hop right into it with the first question. So where in the cell does the ETC OxPhos occur, and what about within that molecule? So within the cell, we know that the ETC takes place in the mitochondria. And now the second question is asking, what about within the mitochondria? So if you guys remember from lecture, she talked about the mitochondria being a two-membraned organelle, right? So what that means is that we have an outer membrane, we have a space between the outer membrane and the next membrane called the inner membrane, and then we have that fluid-filled space called the matrix, right? So within the mitochondria, the ETC OxPhos occurs within the inner mitochondrial membrane. So in this case, they're asking about where it occurs. So it occurs in the inner mitochondrial membrane, also the intermitochondrial space, and the matrix of the mitochondria, right? So it would be a completely different question if she asked where in the cell or where in the mitochondria is the ETC located. If it was where in the cell is the ETC located, then that specifically is the inner mitochondrial membrane, right? So now if we go to the second question, what is a reduction potential? So a reduction potential is, just as it says in the name, the potential of a molecule to be reduced, right? And if something is reduced, that means it'll gain an electron, right? If you guys remember from Gen Chem, Leo, Gur. So Leo is loss of an electron is oxidation, and Gur is gain of an electron is reduction. So reduction potential is the likelihood that a molecule will gain an electron, right? So in this case, if we're talking about reduction potential, you should know what it means to have a low and negative reduction potential value versus a high and positive reduction potential value, all right? So now going to the third question, in what way are electrons transferred from high to low or low to high reduction potential along the ETC, right? So electrons are going to be transferred from a molecule that has a low reduction potential to a molecule that has a high reduction potential. So from low reduction potential to high reduction potential. So this is kind of giving you a kind of general overview of it. You guys should be able to say what molecule in the ETC has the lowest reduction potential and what molecule has the highest reduction potential, and where those are found within the ETC, right? And now if we go to number 4, now we're talking about the 5 types of electron carriers. We went over these kind of briefly in class, but the last 2, or the ones that I'm going to deem the last 2, are going to be the most important when looking at the ETC. So first, we're going to talk about dehydrogenase enzymes, right? These are one of those 5 electron carriers. The second one is going to be those flavoproteins. Then we're going to have the iron sulfur proteins. And then this is where we get to the important ones, right? So we have CoQ or coenzyme Q, and then we have cytochrome C, right? So these last 2, you should know a little bit about their structure. Where specifically in the ETC do you find them? and the number of electrons each carries. So if we're talking about CoQ, we know that CoQ is found within the inner membrane, right? Within the inner membrane. If it's within the inner membrane, then that tells us that this molecule, this coenzyme Q, has to be small and a hydrophobic molecule, right? Because that is the only way that this molecule can be found within that phospholipid membrane, right? Versus cytochrome C. Cytochrome C is found within that intermembrane space. So that intermembrane space, if you remember, is going to have ions flowing in it, and it's going to be a fluid-filled space. If cytochrome C is found within this intermembrane space, it has to be a small and hydrophilic protein, right? Because that is the only way that it'll allow for it to do its function. If it was hydrophobic, it wouldn't be found there, okay? So if you would like to go through the rest of these questions, if you would like to ask me any questions, my email is going to be in the description below, but also come to my sessions, which are Tuesdays and Thursdays from 1 to 2 p.m. All right, and the Zoom ID meeting link or number is going to be found in the syllabus that Dr. Dingwall has posted on Canvas. All right, have a good day.